a case study of gold. You understand? So we're going to look at this, as pertains to gold. The Pathfinder element, we said what it takes last time. These are trace elements that geochemically, associated with the target mineral that you're actually interested in. There are trace elements actually interested in. If you're interested in gold, there are kind of trace elements you are looking out for. If it's lead zinc, you're looking out for certain ones. Like last time we discussed about lead zinc exploration, and we talked about the kind of element that we'll be looking at. But today we are looking at gold, which we also know that gold is not as common as lead and zinc. So gold is actually most of the time occurs in a very low concentration. And this cannot be detected in most cases directly. Even geophysics cannot detect it directly, but we use some indirect method and some other secondary method in the early stage of sampling and methodology that may be employed in this. So this is what you need to know. And typically, when we're talking about some of these trace elements, we look at something that is more abundant than the gold, and something that is more mobile, and something that is traceable. So if they are not traceable, they are not mobile, they are not abundant, you might not be able to use them as trace elements or pathfinder elements in gold exploration. So now what are we looking at? So we're looking at something that can easily form geochemical halos. Geochemical halos is something that can form in a larger concentration. So can form a ring from the inner to the outer core. Do you understand? So these things help you to actually find the areas you can actually concentrate. Imagine when you're given a lot of cadastral units and, you'll be confused. Even after narrowing down using some remote sensing, where you can actually focus can still be a problem, because most of the time the gold and the veins you are looking for is just in a very lower concentration. So you need something that is geochemical, traceable, for you to be able to know the best place to go. So, and you need to understand any mineral you're looking for, the behavior of that mineral and what is around it. And gold being an inert is immobile and really forms like some other minerals, like extensive geochemical dispersions. You can just not see anything, detecting gold with your XRF directly or some other kind of method of sampling. But sometimes if they are not actually being carried to the weathered zone by dissolving in some acid solutions, you might not actually get a trace of them, but they are there. So in contrast to some other elements in here, you remember last time we were talking about lead and zinc, we did not talk about arsenic, even though arsenic can occur, but arsenic cannot actually occur like much concentration like what you see in gold. When you talk about gold, you talk about arsenic. No, arsenic is number one. There's a video I did last time on arsenic, a work we did in Ghana and all that. We talked about arsenic. Remind me, Tara, so maybe you can get a link to that. We did work on arsenic within the lateritic zones. We're able to find out that arsenic is number one in the whole aspect of the entire locations that we did our work on. So when in contrast to other ones like arsenic, the antimony, mercury, these are high, some of these elements are not something you can easily detect. But once you find them, in most cases, be sure that what you are looking might be here, might be there. And also they reflect hydrothermal activity in most cases in this. So in terms of that, if you're looking at arsenic, these are the major ones that are actually associated worldwide. The arsenic, the antimony, the mercury, the copper. There are this Italian statement that always said that when you find copper, you find gold. Though in some places not, but most of the world gold deposit might have some copper in mine. Some may have in major traces, which is actually related to, maybe related to some indicating an intrusive gold system or copper porphyry kind of system. Even lead and zinc is also pathfinder elements. Definitely lead and zinc, because of the hydrothermal alteration zones. Definitely you get that. Bismuth and selenium are also there. But we are going to look at, looking at what generally in different kind of deposits we've seen around, especially in the West Africa, what is the major type that you actually are occurring. There are so many elements, but what are the priority, what are the, in terms of what you see. And we are going to also look at some deposits so that you have an idea. It might not really be a particular kind of element generally for everything, but they are actually based on, on the kind of formation or the kind of deposit you are looking at, whether it's orogenic, whether it's shear zone hosted kind of gold, or whether it's polymetallic, or whether it's can, or whether it is intrusion related porphyry kind of gold, or epithermal or quartz veining kind of gold. All these plexar gold, all these have a different elements. But if you look at these top pathfinder elements in most of the West African countries, you have to start, you cannot do without arsenic as number one. You talk about antimony, mostly found in all these sulfide-rich gold. And if you look at all of them in the West African gold, all the major regions, regional structures are trending northeast. Like in Nigeria, you look at within the schist belt, all the western structures, you go to the Anchor schist belt, you go to the western part, you find out that most of the regional structures are in the northeast. If you go to the Permian the volcanic regions of Ashanti regions or the Asankragwa regions, where the real gold are actually found within the West Africa, you find out that all the structures are actually within the northeastern trend, So that is just it. So if you look at this now, this is in terms of priority, you see that. If you come to Nigeria, also the same thing. Iron, you can't talk about trace Pathfinder without mentioning iron, especially the hematite that actually rich in pyrite. These also, I've seen that a lot in Nigeria. So looking at this, the arsenic, the antimony, the lead, the zinc, the copper, the bismuth, the silver, and the tellurium and tin. I worked in the tin jaws of Nigeria. I found out that the tin jaws of Nigeria contains also gold in high quantity. Also, there are some associated traces of gold when we carried our tests. The same thing there. So iron is there. It's almost in everywhere. You definitely have to see that there increased activities of oxidation when you talk about this. But the key observations in Nigeria, when you look at the Elisha area, that orogenic belt terrain, definitely you will see what we are saying. Then look at some of the areas that are actually dominated with quartz veining kind of system, and some soil that is actually overlying the quartz veinings. You will see the arsenic, the bismuth, and the gold anomalies easily detected when using your XRF. And most of the areas that actually have a high lateritic cover, might definitely dilute some of these gold, but they will enhance Pathfinder halos. So that's why most of the laterite regions, they give you a lot of signatures. So it's a nice place to look for lateritic crusts or lateritic regions while also exploring in a green field. Some places in the northern Zamfara, like in Kaduna, you see some of these things. Then some of the areas, where you see the ASM activities, you see the lead zinc arsenic kind of associated trace elements within the enrichment alongside where the artisanal guys are actually working. So, and if you come to the middle belt areas like in the Nasarawa area, the hosted sheet belt, you see the same thing also. The arsenic, the bismuth, the copper anomalies within there. You can actually correlate these. So these are some of the key observations, I think, in Nigeria. But if you go out of Nigeria, looking at some other world-class deposits, some of the examples, Pathfinders, are actually listed here. That of the UX, the same thing, arsenic. Now, if you look at all of them, you can find out that something is too common. The arsenic, the copper is very common. The bismuth is common. Bismuth, the copper, the arsenic is actually very, very common in Ghana, in Australia, in Guinea, and in the US. And these are world-class deposits that actually been studied. Then some of these things, you cannot, most of the exploration of gold, you need to start with some of the traces because of the minor occurrences in terms of concentration of gold. And this gold most of the time are immobile in soil. And because of that, we need to use some other ones that are actually mobile. And it's cost effective when it comes to, in doing this in the first place. Then the like I've said this before, in terms of the behavior of gold, why we use this is because of it's stable and inert, and it's actually associated definitely with the hydrothermal fluid. And the hydrothermal fluid are actually associated with some of the known elements that we actually looking for. And definitely this must be found in structural zones. So that means that the basics would be that you need to first of all define a structure. The structure holds this. When you're able to define a structure, then you are good to go. Then I've just said it, the common pathfinders we look at. If the arsenic are found is out, the antimony, and in most cases, the mercury, but they are not in every mercury is not easily detected in most cases. But I think you can easily see that of arsenic, the copper, the lead, and zinc. The bismuth also not that easily detected from my experience, but the sulfides in the pyrites actually can easily be found in the lateritic region because of its association with oxidation zones. Then we look at some of these applications. How you definitely the orientation survey is number one key. Not just trying to survey, or last time we talked about the grading. We talked about the methods of trying to carry out some systematic methods of sampling, through the soil. Definitely, you can do some stream sediment or rock chipping sampling, and also identify some of these things, then try to do multi-grading or multi-element grading at the end of the day, after you might have tested using XRF or ICP-MS. So these are some other things, easily tools you can use that is cheaper before going to fire SX at the end of the day, because you don't start with fire at the first time. Definitely, you might be able to do this, first of all, if you have a very large area, to narrow down to some smaller area before you be able to, at least you need to establish some geochemical halo zones and vectoring relationship before you be able to say, go to some higher level of testing that might be costlier, So another one is your geochemical actually mapping. This can indicate, one, it can indicate your proximity to areas of mineralization, the way the fluid is actually flowing, because some anomalies when start from some certain locations and diminishes as you move on to another locations. And this definitely will give you some idea of some alteration zones, like the potassium alteration, the sensitizations, the calcinizations, and some other kind of alteration that actually involve with with our gold exploration. Okay, if we look at the case studies like in the orogenic locations, the belt, last time we did about these settings, the sampling. Sampling is very, very important. And I asked questions why. I think the one we showed last time was about 200 by 50. Most of the time you can sample, the more your grade are denser, the denser your grade, the higher the resolution and the better your result. We said it and we said why. I will give some practical example using some ArcGIS graded map. Then once this is actually done in the right way, we say that a Pathfinder anomalies can actually lead to discovery at the early stage, Then also, after you might have done this, I think the very importantly is the interpretation and the association, how you can actually associate one element to the other, because there are elements that are associated with, that are common bodies that are actually associated with one other. Copper bismuth indications, the lead zinc and the alterations, the arsenic and the bismuth and antimony, Now, if you see this association, it needs to make sense. Having a concentration of element in one location doesn't just give you, but this classes and these association or these pathfinders have shoots. Lead zinc is a shoot. Copper bismuth is a shoot. Arsenic, antimony is a shoot. So if these shoots can be married together, do you understand? And they are occurring and coinciding to a particular location that can form a target for you. But if they are in such a way that in haphazard manner, it might be a problem for you to determine target. So when the target becomes very difficult based on suits of the element, then you need to be very careful that you're not found target zone. But looking at all this, having understood these Pathfinder elements and their importance, it's very, very important to understand that they are very good to use in the early stage because of they can easily be detected. And again, they can show you wider dispersions of halos and definitely use in the early stage before you start targeting and start some other ground geophysics work that might be much, much more costlier. So that is the advantage of that. But in also doing this, you will need to understand there is a limitation and considerations, when doing that. We've said it in terms of limitations. If you're not careful, you wouldn't know that. You should understand that deposits actually vary. Deposit vary. Deposit vary from one location to the other. And not only that, you look at the weathering. The weathering is also an important also an important factor to look at here. Then you also understand that you need to integrate whatever you are doing, require to integrate them with geology. Now, if you don't integrate whatever result you are getting with geology, you might be making a mistake. The geology is the basics to rest whatever you're trying to factor in or vector in, into a grid. Then also understand that different sampling or different elements actually being affected by movement and mobility. So these are some of the limitations. So you should be able to know when certain weathering has actually occurred to move element definitely away from the real targets. These are another thing. That's why it is good that you be able to look at your resolution of whatever you are doing and look at element sheets to coincide. So you don't just look at one element sheet in doing whatever you are doing, but you must look at the priority Pathfinder elements. Then some of the tools, like we just said, I think the most common one will be, this is the tool you can use, the XRF analyzer, the ICP, MX, or OES. Then your mapping, softwares like GIS and IOS gas. These are the real tools and techniques that are common that one can actually deploy. Then I need to recommend in summary that one, you need to start with the orientation surveys. Your surveys and your grading must be systematic. At the end of the day, we're going to be asking for, there are some 4 geos we just selected. I don't think, okay, they've not started the work, but they're going to start the work on something like this. We chose 4 persons last time to go to the field somewhere. They are traveling somewhere to Niger State. They'll be doing about a month's work, field work there. And the first thing will be to start with the orientation survey, which is you form a grid. And in our last class, we said why we should form a grid and how we're going to form the grid. Then the essential tools that is required, you have to look at them. Then you look at the common pathfinders. This is just the summary of what I've just told you now. The right survey system and grading system. Secondly, is using the right tools to do this work. And third, in interpretation, getting the right element sheets, all coinciding and being able to point out your target region. Then I have some field activities I've done here. I'm going to show you some of the pictures, and these pictures definitely we'll be looking at them, and I want you to ask questions from those pictures and explain also some certain things you might be understanding from these pictures, and we'll have some reflection questions. This is a picture. Look at this one here. I think this is a sampling we did some time ago. This is more of lateritic layers. That's actually what we did here. And you can see the packaging well packaged, well labeled, and sent for. This was done. We used the fire assay here, we used the XRF here to be able to get the elements. Then look at this picture also. What do you think here? Any picture you see here, I need you to note it. Note these pictures. This is there is something on this picture. I might want someone to look at it. Also, this picture is showing some kind of structures here. You know, that's why we picked it. Look at also this picture, this and the other ones. Look at the color of the picture. Look at the lines. You're looking at it. Then what do you think about this? Then look at this also, this picture here. Look at it. There's some discoloration somewhere here and there. What do you think is happening here too? Then look at this and the other one is the same thing. This is also a rock that was so picked. This is, what do you think is this rock? Then look at this also. What are you looking at? What do you think this looks like? You know, we need to actually label it. I don't think I would have labeled it so that you'd be able to refer to it. But after now, we're going to look at the slide where it is. What are you seeing here? Then look at this picture. What are you looking at here? What do you see here? All these pictures are field pictures from the gold work. Look at this also. This is the environment of where some artisanal guys are mining. Then look at this also. What are you looking at here? What do you think is this? You know, then that is the end of the picture we have here.